Alright, so before we go too deep, I just want to get a high-level concept in here. So, the camera class itself no longer owns anything, any data. If you go in here, it only owns this iterator that points to a pooled resource. You'll notice that design looks very, very similar to what we did on the graphics system, where the graphics object is instead holding a pointer or an iterator to its own graphics object data. Exact same idea. So before I go into why the camera system needed that same pattern, I want to explain what that data is made up of. So for starters, I was being a bit misleading with the naming. The camera data is actually, what it's actually owning is a camera data double buffer. The double buffer is actually made up of those two camera data objects and the X3D audio listener. Again, I'll go into the audio system and where I got with that, but just accept that he needs to be here. So whenever you say like set orient and position, what you're actually doing is saying update buffer set orient and position, and then marking this as a dirty double buffer. Dirty double buffers need to be cleaned. That's basically all it means. So the camera data object is where you actually have all the old data. So why we need to do this split is because of this synchronize. In the data in the camera data double buffer, man, that's a mouthful. When you synchronize it, all you say is current state synchronize, and if it's dirty, meaning it needs to be synchronized, you call, or that specific state will call this state call synchronize, and it'll set the observer buffer equal to the update buffer, and then tell the X3D audio listener to be equal to the observer buffer. And then you mark it as clean. That's it. Basically, if you change the data, you need to make sure that the observer matches the current update. I refer to it as observer because it's no longer update and draw. On the graphics system, there's only two main parts of the engine that would reference graphics. It's the update buffer, which is what the user is interacting with, and the draw buffer, which is what the graphics system is reading from. And this, in the camera system, I refer to it as the observer buffer because both graphics and audio are both referring to the cameras in valid cases. So by not saying draw anymore, it's a bit more clear. So now you have the idea of the camera now has an iterator that points to a camera data double buffer, which owns two cases of camera data. So why is all these layers necessary? So we'll step it back. So when you say acquire camera data, what you're actually doing is getting the engine scene. Actually, here we go. The engine scene. So this guy is necessary. Okay, we'll step it back one more step. So what I found when I was creating this system was I needed the idea of being able to create the engine resources that are relevant to the scene, and that's where the engine scene comes in, then create the graphics resources, and then create the user resources. It has to be that order. So that's why I broke the user scene and the engine scene apart, because the graphics data needs to be done in between there. So now that's out of the way, engine scene exists. He has basically everything that the user doesn't have. So you go to the camera manager. Now the camera manager is where that data actually is owned. The camera manager owns a camera data manager, and in here, here's all your pooled resource pools. Here's where all those camera data buffers actually live, on this guy. So why do we do all these steps of managers within managers and resources and resources? The reason was, let's say the user creates two cameras. Camera A is the current perspective camera. And then a few frames later, they create camera B, set camera B as the current perspective camera, and then delete camera A. The problem with that is now camera A is being deleted in the same frame that camera B needs to be assigned as the current perspective camera. But we cannot reassign the current perspective camera in the same current frame. We have to send a command to do that. Again, commands are very, very useful here. We can't set the perspective camera in the same frame because graphics and audio are both referring to that camera, and there's no way for us to do that, to swap that pointer properly, without doing a lock, which is just not okay. So you have to first assume, alright, we cannot change the perspective in the orthographic camera mid-frame. So you send a command to do it the next frame. But the problem with that is now user just deleted camera B, or sorry, they deleted camera A, which is valid, without being able to reassign camera B to be correct in the same amount of time. On the same frame, sorry. So, this guy actually saves us. Because the user, when they delete the camera, doesn't actually delete the resources underneath it, that data is still there. So during that weird case where the user submits a command to request camera B to now be the perspective camera, then delete camera A, when he releases that resource still exists in here. So this pointer, the current perspective camera, is still pointing to that data. So the graphics and the audio system are still referring to that old data even though the user technically doesn't own it anymore, and the object that was previously owning it got destroyed. So then the next frame, this pointer will then get reassigned. So that, in a way, allows the user to just create and destroy memory, set and reset the perspective and the orthographic cameras all willy-nilly, and no matter what they do, it'll be thread safe across the three major sections of our engine. Again, I've been distinguishing it as graphics, audio, and update. Update we need a better name for, but that's basically where all the user stuff is done. So these pointers, combined with the resource pools, help keep all those things in line. So when we back it up, engine scene owns the camera manager, that owns those commands, the set perspective, set orthographic. And there's, I refer to them as command calls. That's just the calls that the commands call. That's when you actually reassign it. You see, you set the orthographic camera. And so this helps protect us. Yeah, there was just, the deeper I went into this, the more I realized that there were so many potential race cases that our simple little demos didn't really do a lot with. We didn't change, delete, or create cameras a lot in our test scenes, and there were a lot of use cases that were fairly valid, weird, but valid, that would have destroyed our poor engine before. So this was very needed, and I'm glad it's done. And actually, you'll see in here, when you set the engine to ignore trivial tasks that are so quick that it doesn't matter, I think it's beneath 00001, or I think it's 5 zeros. Either way, it's such a small amount of time that's done right here. This chart's a little outdated, but it's done at the same time as these guys. It's so small that it doesn't matter. Resolve frame will always be bigger than it, unless the user literally has hundreds of cameras. That's the only way that they could do that, which is on them if they do that. So it's very cheap, not a big deal to the rest of our engine, and gives us just an enormous blanket of protection against any sort of user shenanigans.